I love me some good peanuts. Oh, hey, I didn't see you there. I want to tell you about my project, study of size separation of sub-millimeter sized granular material using vibrofluidization. Granular convection is a phenomenon whereby large particles rise to the top of a vertically shaken container. It is also known as the Brazil nut effect. So, for example, if this container had any Brazil nuts in it, which are quite large, they would rise to the top. This research can be useful for 3D printing of metal powders, which require mixtures of powders of a very unimodal size distribution. I worked on this project over the summer at the Naval Research Lab under the guidance of Dr. Scooter Johnson. I created the data collection setup, collected nearly all the raw data, completed all data analysis, and formed conclusions. My mentor served as an advisor, taught me how to use equipment, and used the SEM and XRD machines, which I was not trained to use. So far in this field, much research has been done on granular convection, but little to no work has been done on particles on the sub-millimeter size scale, which is the size range where granular convection has more potential applications. My work studies granular material at this size regime, measuring the time to reach separation and the purity of separation of particle mixes. Mixtures of 70-micron tungsten carbide and 50-micron yttrium-stabilized zirconia, or YSZ, were made in different volume ratios and placed in glass tubes. These mixtures were filmed while being vibrated, and the videos were then analyzed frame by frame to track the progression of separation of the powders. I was then able to create an exponential decay function that models the time of particle separation versus the vibrational amplitude. The purity of separation was quantified with XRD and SEM techniques. When the tungsten carbide was separated by hand from the YSZ after being vibrated, about 90% of the tungsten carbide that had been initially put in the system was reclaimed, and the reclaimed tungsten carbide was actually 95% pure. This high purity is remarkable considering the closeness of the particle sizes involved. With this level of purity, granular convection could be used for all sorts of refinement applications. Thank you for watching. I will return to my nuts now.